Welcome to our first lesson, linear programming. Now, let me start by saying linear programming, we are going to deal with variables under given condition so that we may not exceed some limits. So I have taken an example here. The manager of a cinema wishes to divide the seats available into two classes. So there is a cinema hall, there are seats. Those seats are to be divided into two classes. Okay? The following are constraints. So these are circumstances that will lead us to the cinema show. Constraints. One, there are more than 100 seats available. There are more than 100 seats available. And the seats are in class A and class B. There must be at least twice as many B class seats as there are A class seats. Okay? So there you have really to comprehend that sentence, that the B seats must be twice as many. That is at least. Okay, then class A seats are priced at 30 and B at 20. And for the show to commence, the minimum we require for any show is 2,000. Okay, so what is the key thing in linear programming? You sort out the question in terms of what is the core, what is the question addressing, what are the items, or what are the nitty-gritty in that question that need to be enumerated. And then you have to understand the symbols, greater or less, the words at most, at least. So let us look at our example here. I give you one example here. I've sorted out, tried to put this thing, maybe I can focus on both the constraint and this. You can see now the constraint number 1. Okay, before I go to constraint, just see the core. What is the core subject? I'm dealing with the cinema hall. What is the nitty-gritty of cinema hall? There must be seats in that cinema hall for people to sit. And what is the number required of each? So write down the inequalities from the constraint listed above, taking X to represent A seats and Y to represent class B seats. So we have been already told what to represent class A and class B. So I come, core subject, cinema hall. Okay, that cinema hall has seats and a particular number of those seats. Then I come and classify that in that hall there are class A and class B. The number of A is X, the number of B is Y. So I know the core subject, what are the requirements in the core subject, then come here, classify and give them variables, X, Y. Then now address the constraint. We are told, if you can check the very first constraint here, there are not more than 120 seats available. So seats cannot exceed 120. That's why we have the first. Okay, you check there, the first constraint. Okay, then number 2, there must be at least twice. Here we are, constraint. Let me go up a bit. Yes, I'll finish with that one. So there must be at least twice as many B seats as there are A class seats. Okay, at least twice. So B the worst is twice of A. B is twice of A. That is the key thing. B is twice of A. So somewhere I must have 2x because number of seats of A is x. So somewhere I must have B greater than 2x. But look at it in another language. Another language is here that B to A must be greater, that ratio B to A must be greater than 2 to 1. So B over A greater than 2 over 1. Put it another way, y over x greater than 2 over 1. If you cross multiply, you come with y is greater than 2x. Third, class A seats are priced at that. Okay? So we are given the price of each seat and we are told the worst we can collect is 2,000. So I combine 30x plus 20y must be greater or the worst is 2,000. Now, remember, core subject in the question, what is involved in that core? Seats and number of seats. That is the first line. Come and try to classify and put the variables that you have been told. Then number 3, address the constraints. Okay? Now, when you do that, you will come up with a graph now. That is the graph. In the graphing, you must know what comes first in case of inequalities. It is an equation. We have an equation first drawn. Equation. After the equation, you write the line of that equation. The equation of that line. You write the equation of that line. So first, you remove the inequality sign, put equal sign for all of them. Then write the equation of that line at the end. Then shade accordingly. So you will remain with unshaded area. Like me, I have this is my unshaded area remaining, this part. It is from this that you get the answer. Normally, answers would come from the points of intersection, but not necessarily always. So what you do from that variable, profit variable, from that equality or relating the profit, you can use any constant so that it becomes a search line. Then you can use search line to get any answer you get, be it here, any point, these points, anywhere. You must apply the x and y coordinates according to the constraints which were given. So don't just pick and think you are right. No, you pick and see, does it obey those constraints? If it doesn't, then that is not the answer. There will be one which will obey the constraint. So try this on your own and then get to know how to get inequalities first. You go step by step. Get the inequalities. How? How do you get the inequalities? Remember what I did here. You must have core subject. What is entailed in the core subject? Okay, this is what is entailed in the core subject. Then you classify. What is it there? Information, the information that is given. It requires classification. Put your classification here. Then the number according to what you are told to take here. Then address the constraint one by one. But don't expect that you will be given constraint 1, 2, 3, 4. I've given you this so that you, just to open up your mind, that normally you will get constraints. There will be 2, 3, 4, not more than that. They will be contained in sentences. I have decided to do this to help you. So next lesson, I'll not do 1, 2, 3. No, we will be reading so that you see how to get them from the questions themselves. Thank you very much. We meet next time.